Good afternoon, class. So we're going to start off this live lesson recording for Unit 5, Lesson 4 notes, which is called Evaluating Roots, with a little bit of review. So I'm going to very quickly go through these reviews because these questions were in Lesson 2 and Lesson 3 recordings. So just as a reminder, when we are adding and subtracting radicals, we have to make sure they have the same index. So in other words, the same root. So this one has an invisible 2 here. So if there is no root, like there's no index there, there's no little number above the root, then that means it is automatically a square root. So you can just kind of put it like a little invisible 2. So it has to have the same root and it has to have the same radicand. That's what the number under the radical is called. So since this has both of those things, we can just subtract the coefficient. So the coefficient, again, is the number that's in front of the radical. Or the root symbol. So we have 4 minus 2, so that would be 2 square roots of 3. All right, and with question number 2, we've seen this one a couple times probably if you've watched the Lesson 2 and Lesson 3 notes. So we just add these two. Again, if there is no number in front, there is no coefficient in front of the root sign, there's like an invisible 1, because 1 times the square root of 6 is just square root of 6, because 1 times anything is just that number. So we have 7 plus 1. They both have the same index, which in this case is 2 because there's nothing there. And then they both have the same radicand. Both are square roots of 6. So then we would just add the coefficient. So 7 plus 1 is 8. So that's 8 square roots of 6. All right, Lesson 3. With this one, we said we just multiply the roots. So that would be negative square root of 21, because 7 times 3 is 21, but this has a negative out front, so that's why it's a negative out front here. So negative square root of 21. This one, we can divide, so kind of like what we just did here, we just multiplied the two numbers in the radical. Here we can just divide them. So we have 4. And then 10 divided by 2 is square root of 5, because 10 divided by 2 is 5, so 4 square roots of 5. When we are simplifying, we have to use our perfect roots. So I actually have a chart down here that shows the perfect roots. And again, we're just trying to find the largest perfect root that we can pull out of that particular number. That's the largest factor that is a perfect square. So in this case, that would be the square root of 100. Is a factor of 200, so we could break this apart to the square root of 100 multiplied by the square root of 2, and then the square root of 100 is 10, so that's 10 square roots of 2. And I know I've done this before, but just to prove that that is the case, I will just go ahead and show you that the square root of 200 is equal to 14.14. And now we're going to do 2, oops, sorry, that's not right. Go backwards. 10 times the square root of 2. So 10 square roots of 2. So you can see these are the same, 14.14. So they are exactly the same. So we didn't change the number. We're simply simplifying it. I just said simply simplifying it. That's kind of funny. All right, anyways. All right, so same thing here. We're just trying to pull out the largest perfect square that we can pull out of the square root of 12. So 12, if you think about the factors, are 1 and 12 and 4 and 3. Well, the square root of 3 is not a perfect square. The square root of 4 is, though. So we would break that apart to the square root of 4 times the square root of 3. And we still have this 12 out front. Okay, because we can't just get rid of that. K squared of 4 is 2, so that's 12 times 2 times the square root of 3. And then 12 times 2 is 24. So this is 24 square roots of 3. So again, we're just pulling out the largest perfect root we can out of the number, which in this case is 4. All right, now we're going to go ahead and jump into evaluating roots. So for evaluating roots, this one is pretty simple. We're just looking at the square root of 64. That's 8. So that's literally just 8. Square root of 121, we can see here on our chart, is 11. So square root of 121 is 11. So again, you could use your calculator too for that. Like we could do the square root of 121 And we see that it is 11, because 11 times 11 is, in fact, 121. All right, the negative square root, the cube root of negative 343. So if we look at 343, that is equal to 7. Okay, so the negative cube root of, the cube root of negative 343 is negative 7. So if you think about that, what that means is that negative 7 times negative 7 times negative 7 is equal to negative 343, which in fact it is. So the cube root of negative 343 is negative 7. All right, cube root of 100. Now that one's a little trickier because notice that there is no cube root of 100 on here. Okay, so we could do this a couple different ways. First, we could figure out if any of these are factors. So if we look at our perfect cube option, so we can just kind of ignore this one. We're not ever going to pull out a 1 out of anything. Okay, but 8, does 8 go into 100 evenly? It does not. Neither does 27, neither does 64. So we're just going to use a calculator for this one. So to find the cube root, we're going to use this button right here. So this is square root. This is for any time it's just a square root. Okay, but we don't want that. We want a cube root. So we're going to hit this button, the n with the root symbol, and then we're going to change the index. So again, the index is what root we're using. So this is a third root or a cube root, and then we're doing the cube root of 100. And so we're going to approximate it to be 4.64, we'll say. So approximately 4.64. It's not exactly, but close. And that is it for unit, what is this? Unit 5, lesson 4 notes. So a lot of it was review, but we have a few that were where we're just looking basically at the chart or just using calculator to figure out what the answer is. So like you could technically use a calculator here as well. We could do the third root. So let's just go ahead and do that real quick. So, whoops, enter there. All right, so we'll do the third root of negative 343, and we get that it is negative 7. All right, if you guys have any questions, feel free to reach out. Otherwise, have a fantastic rest of your day.